Welcome students. In our previous class we have studied about light, right? Light and some of the phenomena related to light. So one is reflection, refraction, transparency. All right. So we have studied about reflection, refraction and transparency in terms of light, right? Let's do a little bit of a deep dive and understand more about light today. All right. So today we are going to study about spectrum. Okay. So spectrum. So spectrum of light. What is a spectrum of light? It is a band of colors. Okay. In simple terms, you can understand it like that. Okay. So it is a band of colors. And what are those colors in that band? So whenever you see a rainbow, you see 7 colors, right? Which is often denoted as Vibgyor, Vibgyor, and all these are acronyms. It stands for first letter of the color, right? We'll talk about it. So, what is the spectrum? Let's say you have a prism. All right, and a sun ray passing through this prism. All right, so this is a transparent object. Sun ray is passing through this prism and it gets refracted. The phenomena is called refraction. All right, so the light gets refracted, and let's say you have a wall and these lights get refracted and you will see all those on the wall like this. All right, now this is called a spectrum because it has the band of colors, right? And this is a band, a combination of 7 colors. Now these 7 colors are from the low wavelength to high wavelength. Okay, so low wavelength to high wavelength. All right, so lowest wavelength is of this violet, then I, indigo, then blue, then G, green, then Y, yellow, then O, orange, and then R, red. Right? So you have the wavelength, low wavelength to high wavelength. Now, red being the highest wavelength, what does the high wavelength mean? Right? So a wavelength is a wave that passes in a sinusoidal way, right? So higher the wavelength, slower it will take to pass, right? So red has the highest wavelength. That's why whenever you see the color of the sky or setting or sun rising in the sky, you will see the color that is of highest wavelength, that is red. You won't see all other colors. Otherwise, you will see the white light. So what is visible to us is white light or red light, which has the highest wavelength. All right. Now this wavelength is related to a term called frequency, right? So when you talk about wavelength, it is denoted as lambda. We will talk about this in future classes. So this is denoted as lambda, and there is frequency which is denoted as like nu. Okay, so this is lambda and this is nu, right? So a wavelength is like I said, it is a sinusoidal wave that passes through any object, and frequency is number of waves that passes through a point in a second, right? So frequency is measured in hertz. That is the unit to measure frequency. We'll talk about that in detail. But for today's lecture, I will just tell the relationship between wavelength and frequency, which is wavelength is inversely proportional to frequency. Meaning, the larger the wavelength, longer it will take to pass through one point in a second, right? So if the wavelength increases, the frequency reduces, right? So if you have a higher frequency, that means more waves passes through a certain point in 1 second, right? So we'll discuss about this, then you will have more idea of what wavelength and frequency is. But for now, you understand that a spectrum of colors is 7 colors, which is VIBGYOR, and you can find it by using any experiment using a prism, where a sunlight or any light that passes through the prism and it gets refracted, and you can see the image in any wall and any other opaque object, right? So this is it for today's class. We'll continue about this in next lecture. Thank you.